Okay, so hi everyone. This tutorial, in this tutorial, I will introduce the majority of steps for image classification. Um, Image classification, as discussed in class, basically. So for this lab, we will want to cluster or separate and features based on their spectral signal or spectral responses. Right? As we discussed um, uh, in the class meetings, right? So water features always have low um, response or reflectance for red and infrared bands, right? For the vegetation, the spectral response or reflectance will be much higher in infrared than all majority of other features. However, their reflectance in red band will be low, right? Will be low, right? Because of difference in spectral responses, then it is possible to separate the land features. And of course, the results won't be 100% accurate. I will discuss this in a next tutorial. Um, because like so there will be cases where um, land classes belong to the same feature, they may have some slightly different spectral response. And then it's likely that land feature may be classified as a different class. So that's common. That's common. And our job is to make sure that the accuracy of the classification results as high as possible, and which I will discuss in the next tutorial. Okay, so and of course the results of the classification can be used for many other applications, like for planners, soldiers, geologists, and yeah. So image classification or thematic information extraction from satellite images is perhaps one of the most common or the most common remote sensing applications. Okay, so next we'll start the classification. Before we start it, of course, we'll always want to. Okay, I couldn't find my. Okay, cursor. Okay, so I find it now. We want to start. Okay, add the image file from last year. All right. So we'll use um its bind to classify images. And again, and we want to show it in standard false color composite. Right? And we want to show the world imagery layer. So that if we want to interpret land features, we may refer to this layer. Right? Okay, so now, well, the layer is selected, highlighted in contents, click on classification wizard. Classification wizard. And we'll use for this class to make sure that we finish the lab assignment. We'll do a kind of simple unsupervised classification. The software will do the job for us. And we will not do object-based. Instead, we'll do a pixel-based. Object-based, of course, the whole image is being separate to different sections. So all those similar pixels being grouped together. So of course it has its own advantages, but to make sure that we finish this lab, we just use the pixel-based classification method. Classification schema. Okay, so how many concepts we want to have for our classification results, right? So we can create a new one, but we can always use a currently existing one. National Land Cover Land Change Detection 2011. So that's used for the states. It's used for states. We can certainly use it basically because land use land cover types are very, very similar wordly, very, very similar wordly. Output location, we want to make sure this the output being saved in the Lab 4 geodatabase. For me, is RS underscore Lab 4 geodatabase. Okay, so then that's it. And next, what method will be used? Right, when the method will be used, ISO cluster, basically that's one algorithm just automatically help us to group or cluster pixels. So I will provide some explanations in the instructions. Please go ahead and read it. Right. So the maximum number of classes we want to have, yeah, by default 5. We want to change to 10. In case we have like several classes in the image belong to one class, then we can merge them later on. So we always want to have a few more or several more classes in the beginning to work with. Maximum number of iterations, how many times the algorithm will want to regroup the pixels, 20, and use other default settings. Please read the corresponding instructions and then click on run. Right, so very, very straightforward. Right, very, very straightforward. Right, it's easy. And now the next step, we may have spent at least 5-10 minutes there. We want to, because the software tells us, okay, so there spectrally there can be 10 classes, right? Can be 10 classes. What are they? The 0, okay, stands for water, right? So 0 is water, and 6 is this brown color, right? So likely that's water, right? So at least, so there are 2 classes of water there. So we need to identify the spectral class in the image first, and then later on we will merge them together and export it. Okay, so what we want to do, right? Click on it, and right, click symbology. Right, so 0, I'm sure it's water. So write down, make some notes. Right, 0 is water. What is 1? 1 is dominant. Right, 1 is dominant here. 1 is dominant. It's here. And what we can do, go to raster layer, click on swipe. Uh, uh, that's forest, right? 1 is forest. 1 is forest. Look at it. 1 is forest. 1 is forest. What is 2? 2 is obvious. Build up or development, right? 2 is build up development. So you just do it, make some notes. Okay, so note in this output, numbers being used as indicator for line classes, right? What is line? Line, yes. So we want to zoom in. Zoom in. This magenta color, right? So that's herbaceous, grass, herbaceous, right? Herbaceous. So line is herbaceous. So make sure you do your job. Okay, so to change the label, it's straightforward. A straightforward one is water, right? And okay, it's okay. Dark blue, right? Dark blue. One is forest. Dark green. Dark green. Right, 2, what is 2? 2 is built up. Right, 2 is built up. Built up, we can use like brownish color or dark red color uh, or developed. What is 3? Okay. You see here, editing the selected value failed. Yeah, because this is a temporary preview, right? It's because now I want to make some additions that I failed. What we can do here, reclassifier. No, okay, we can do what we can do here. We can close this reclassifier here and redo it, right? Right. So here, okay. So before we identify the corresponding labels, it's better for us to. So I just forgot this step in the instructions, and name it as LCLU land class and land cover underscore 2023. Right, export it so that then we can uh then we can manage its labels. Well, so the color changes, that's fine. Right, so then symbology, unique values, right? So 0 is water, right? So we did it already. There is water. Change it to a blue color, dark blue color. Okay, 1 is forest. Uh, dark green. 2 is developed. Dark red or brownish color. Right, and 3, what is 3? Not very obvious, right? So we change the color to a bright red one. Then we should be able to see where they are. Okay, so it's adjacent to forest land. Okay. All right, so the green one maybe denser forest. So the red color maybe not as dense. Still they're forest, right? Forest. All right, then we can change it to a dark green color. All right, dark green color. What is 4? Red color again. All right. Okay. If we're not very sure, right? Still forest, right? Still forest. Still forest. Dark green. Oh, dark green. 5. What is 5? Uh, red again. Okay. Look at here. Look at here, and you might notice that the classification results might not overlay very or align very well with the high resolution images. Yeah, because think about the difference in spatial resolution. This one likely to 1 meter. 1 meter is yeah, normally the open source high resolution images is 1 meter, right? 1 meter, and the lens at 30 meter. So in 1 pixel, signal stored in 1 pixel, length set 30 meters, 900 square meters, right? So mixed, of course, not as accurate, not as accurate. And yeah, so because this area is still being dominated as trees, right? So we might still, yeah, so that's forest, right? Forest. What is 6? Okay. Water, right? 6 is water. A blue color. This color? Yeah, a blue color. And 7, 8, 9. If you want to span the image, use the keyboard, like left or right, up or down, right? Right. Uh, 7, which is kind of forest, right? Kind of forest. Look at here. The forest. The forest. Yeah, okay, still say it's forest. Yeah, if you want to say it is herbaceous, I won't blame you. I won't blame you. Right, what are these? Okay, so the vegetation around the rivers. This is unique. It's combination, right? It is a combination of bare soil and some types of vegetation. Right? Look at here. Look at here. Okay, so sparse. Right? Sparse. Very sparse. Right? Sparse. Right? This is a sparse forest. Right? So it's forest. So it's a forest. Or sparse forest and conifer. So line should be herbaceous. And line should be herbaceous. Here, should be herbaceous. Right? Very smooth. Right? Very smooth. Very smooth. Right? Herbaceous. It could be lawn, could be crop and grass. Right? Herbaceous. So spend time on it. Spend time on it. Question 5, you have to leave the list specific class labels for your classification results. What is, so which means you have to answer what is 0, what is 1. Your results may be different from mine. Okay, the results may be different from mine. Step 2, assign classes, merge classifications, right? Because listen here, I have how many forest, right? How many forest? 1, 2, 3, 4, 5, 6. 6 classes belong to forest. And and of course, I asked you to merge the all these 10 classes to 4 classes: herbaceous, forest, built up or developed, and water for this lab, right? Because it makes the job easier so that you can finish the assignment on time. Right? We can all spend more time on create more classes. Like say, instead of creating 10 classes, we can create 20 classes and then start from there, which means that you have to spend more time on that. I just want to make sure that we can finish it on time. Okay, so right. So now back to image classification wizard. Okay, another reminder is that for these sections, you will want to finish them, like merge classification results, finish them in one time block if possible. Yeah, if not, we get some problems. Okay, we get some problems. Okay, so okay, so now I know. So make sure you write down. Make sure you write down herbaceous, all the class labels, and then click on next on the image classification wizard. Right, so now, so this is an LCD 2011, right? So we only want water, developed, forest, and herbaceous. For other classes, we want to delete it. Highlight it, cross, delete it. Shrubland, delete it. Planted, cultivated, delete it. Wetlands, delete it. Right, and then what you will want to do, right? So now we want to assign the classes, 4 classes here, to these spectral classes here. We want to click on the first column of that class, right? It's been highlighted, and then we click on water here, right? Assign this color to water, right? That's water. Well, so is a class 6 water? Yeah, class 6 water. Right? Class 6 is water. It's highlighted in cyan, right? It's water, right? So then what else? 2 is built up, they are developed, right? And highlighted, right? Sometimes we want to zoom in to make sure our selection is accurate, right? Developed. And 9 is herbaceous. Click on highlight and herbaceous. Click on it. And all others highlighted, we can push the control key at the same time. No, it doesn't work. Okay, we have to do it one by one. Zoom in. So that's make sure it's forest. Right, make sure that's forest. Right, and class 7, make sure it's forest. And class 5, class 4, selected. Class 5, selected. Class 1, selected. Okay, so yeah, so now all the old classes being assigned new class labels, right? So for unsupervised classification, we will let this algorithm find the special class first, and then we identify the exact classes, and then we will assign the class label. So that's the step, right? That's a step. Right, so for question 6, you will capture a picture of the merge classification results. The right, so this window, and insert into your Word document. Right. Click next. Right. Preview class. Right. Preview class layer is created, and now we see that okay. Look at here. Which is still some pixels are highlighted. No worries. Go back. Which class is highlighted? I have no idea. Okay, no worries. No worries there, and we should be able to. We should be able to. Because the colors being assigned is correct. It's correct. Polish. Step 3: polish classified. Classification results. Reclassifier. Right. Reclassifier pane. Right. And as I showed, for example, so there are some obvious classification errors, like here. This is the steel plant, right? This is steel plant, raster layer, swipe. Right, this is steel plant being classified as water. Right? Other areas, same thing. Is that so? That's water being classified as water. Is that water? Oh, that's real water. Okay. Yeah, the steel plant. Right. So we want to manually correct it. How should we do it? Reclassify. Right. Reclassify. Reclassify. Yeah. So manually add it. So we want to all these pixels being classified as water and being converted to the class of developed. The class they are developed. Okay, so what do we need to do? And click on the reclassify within a region, right? Convert from water to developed. Then reclassify within a region, right? So we'll draw like move your cursor there and draw a polygon. Double click to finish it, right? So we want to convert from water to developed. Right, the same should be here, right? The same should be applied here. Uncheck it. Yeah, uncheck it. Those are not water there, right? So, your results may be different. Okay, so make sure you observe your results carefully, right? And how about here? Uncheck it. Yeah. So those are not water, right? So you want to do, and yeah, right, and just checking around, like here. So it's the water there. Yeah, so this is wetland. Yeah, here wetland. Yeah, so there's maybe some. Yeah, right. Okay, so checking around, uh, find areas that you believe the classification may be wrong, and right. Okay, I think I made a mistake. I merged herbaceous with forest, right? So okay, so basically you will follow the instructions. You will follow instructions in the nav manual there to finish it, right? So sorry, I made a mistake just now, and um, so you will make sure you have 4 classes. Okay, you will make sure you want to have four classes. And what do you want to do next? Yeah, so verify. So if you don't want the changes, uncheck it, right? So that's what you want to do. And uh, if you're okay with all the changes, click on Run, right? Click on Run. And the final classified data set as Sue, LCLU underscore 2023 reclassified. Click on Run. So this file will be or this layer will be saved in your lab 4 geodatabase file or lab 4 section 2 geodatabase file. So now there are only 3 classes. This is the polygon I selected. So no worries about it. No worries about it. Okay, so in case if you want to reclassify the reclassified layer, what do you want to do? Right, because after you exported it, you find that okay, there are some further changes I want to make. What you want to do, highlight it and then click on classification tools, reclassifier, right? And then from there, select the layer. and then perhaps reclassify. Reclassify from, say, from water to develop again, or from water to forest. Okay, from water to forest. So that's for step 3. And for step 4, filtering classified output. So look at it. If those areas being classified as built up, normally it will just be built up, right? We don't want to have like this. Okay, so a tree patch there. If just 1 pixel, normally we don't want to stay there. We would want to classify it as developed, right? So, normally, for this lab, we will say if a patch is smaller than 4 pixel, it's 4 pixel, then we'll classify it or convert it to the labeling class, like the case here. So it's 1 pixel, we want to convert to developed. 2 pixels, we want to convert to developed. The technique we'll be using is filtering. Yeah. Yeah, sometimes maybe shadows or mixed pixels, right? So for Philo and like non-use line cover product, we don't want so many details. We want to filter those dangling pixels out, right? Use the majority filter tool. Well, how we do it? So we click on analysis and tools. Start the geoprocessing pane and search the majority filter. Right, that's the first result. Input raster, so should be the RE, right? So LCLU 2023 RE, and output raster. What's the name I gave there? I'll set the SOSLU RE modified or filtered, right? Or filtered. Number of labels to use, right? So if not clear, the kernel of filter should be 4 direct neighbors to the present cell, right? Determine the number of neighboring cells to use in the kernel of the filter. Replacement threshold majority, right? So we check around. If the majority is developed, then it's developed, right? To fill out those dangling pixels, those dangling pixels around. Because this, yeah, those ones would be replaced in most cases. It's wrong. Right? See the changes? The changes? Yeah, sometimes uh it create some other dangling pieces, right? So in that case, we may want to just remove remove the change the number of labels to use, right? Change from 4, 4 in many cases the minimum, but we can do a test, change it to 2, and so that's the result. That's the result. So if the colors not use colors for the new layer change, yeah, we can change it in the symbology, right? Because the labels is lost, right? Attribute table, symbology, right? So 0 is water, right? 0 is water. Change it to a blue color. So we have to wait. Yeah, it's really ridiculous. Hopefully the software does not freeze. If you do freeze, it does freeze. So what we can do, just restart, restart the app, and load this layer, right, from the level 4 geodatabase file, and change the symbology again. So it seems there's some issues. What I will do, okay, yeah. What we can do is push Control, Alter, and delete the key to end the running of the task, to end the task and restart it. Okay, so and for question 7, you will obtain a screen capture of the summary. Okay, so summarization table. So it's very straightforward. You will find the geoprocessing pane and find the summarized categorical raster. We want to know how many pixels is for what, how many pixels is for developed, how many pixels are for forest, right? So use that function to find it, and then do your calculations. Remember, 1 pixel is 900 square meters. That's it. Okay, so yeah, basically I showed you how to change the labels already, right? So in your previous step, so you will need to finish by yourself. I will not wait till the software to respond. So it may take 10 minutes or it may take forever. I don't think you have problem to do it since you have done in a previous step. Okay, so that's for this tutorial.